All right, introducing Weasel. So Weasel is an enhanced version of Wigzel. Hopefully that's something that's useful for everybody here who writes shaders or will write shaders for WebGPU. We hope also that Weasel will show a way forward for the ecosystem, enabling common tooling and shared libraries. These are your Weasel speakers today. Sorry, it was a little hard getting everybody online.
So a quick peek at what Weasel looks like. It is simply Weasel plus local imports from your local file system, imports from libraries that were published to NPM or Cargo, and conditional compilation with @if attributes. Adding Weasel is very easy. You install our libraries, add a few lines of code, and they do what you would expect. And then you are already migrated to Weasel. And because Weasel is fully Wigzel compatible, you can incrementally adopt Weasel features at your own pace.
So how did we come to implement these particular features for our first release? Well, we reviewed the community needs and we spoke to many of you. And we noticed that the most requested features was the ability to split shader code into different files, aka modules. So why not just write your own module system? Well, that's what the community has been doing so far. You can see in green a few examples of different syntaxes for import statements. And in blue, the links are 15 different projects that have implemented their own module system. The issue is that all of them are different. They are not compatible together. So it's hard to develop common tools that can be used and compatible. And this leads to a lot of ecosystem fragmentation. So turns out making a robust module system is actually very challenging. And just to give you a glimpse of it, if you want to implement a module system, you have to implement name resolution. That means avoiding names collisions from different declarations across files. And for that, you would have to implement the correct parser and name mangler. And so just a simple string concatenation approach is not sufficient. And that's why we made Weasel.
So in addition to modules, here are some of the other top problems we heard about from you. Conditions and constant injection to customize your shaders at build time and runtime. Tooling, things like formatters and language servers, which we're having difficulty writing today because of the current fragmented ecosystem. And shader library. If you look around at WebGPU projects on GitHub, you'll just see a ton of wasted effort of everybody copy and paste and editing things, the same things over and over again. So what we're proposing is that projects won't have to rely on sort of ad hoc regex approaches, and instead we can come together around some standard tooling.
So just to give you a little bit more detail on what we're adding to Weasel. And remember, Weasel is a superset of Weasel. It is Weasel plus all of these things. The first of which is the import keyword. You can bring in Weasel or Weasel code from other local files. You can import shader code from other libraries with the same syntax. And there's a dense variant of the import statement to save you a few lines of code. And finally, inline module references are sometimes convenient, with no import statement required.
The second key feature is conditional compilation with a new custom @if notation. Conditional compilation can be applied either during compilation or at runtime, for example, in a browser. Now we have a more complex example taken from Bevy.
And now with a standard syntax and a standardized format, you can easily publish shader libraries to NPM and Cargo. Your users simply NPM install or Cargo add these libraries and can start using them right away with our import statement.
So coming back to the top community problems that we identified, we think that our implementation actually addressed all of them. So we have made two different implementations, one in Rust for the Rust ecosystem and one in TypeScript and JavaScript for the browser ecosystem. And they are both support the same features from our initial release, and they also share the same test suite. So you can reuse the shaders across ecosystems. We also have a bunch of additional tools. On the web, we have a plugin for Vite. We have initial support for syntax highlighting, and more tools are on the way.
Okay, now let me shift gears a little bit, and we'll show you a few pictures of the internal architecture of the linker and some extension features. The library, the JavaScript version is 10 to 20 kilobytes in size, so hopefully fast and small enough for you to include in your bundle. And then you get the full flexibility to customize shaders at runtime. Alternately, you can pre-compile everything at build time and then pay zero cost in time or space. Just as you can feed app and library code to the linker, you can also plug in code generation functions that spit out arbitrary shader text at runtime if you want. Framework and tool developers can also build on top of these Weasel libraries. We've started developing an API to extend the Weasel plugin and linkers. In fact, some of those code samples earlier are implemented as extensions through this API. And the API even gives you access to the abstract syntax tree. You can read it and even modify it. Here's an example from a partner project showing type GPU reflection from Weasel in on the left into TypeScript on the right. And not shown here, but we're also excited about the other direction as well, where you might imagine defining uniforms in TypeScript and then using them in Weasel or WGSL, so both directions. Iwo, who works on type GPU, is waving over there in the audience. Here's another prototype reflection extension from a project called Timefold WebGPU, which also uses the AST API. And here's a prototype extension for a proposed WGSL feature for stable auto layouts. It hints at the ability for Weasel to prototype future WGSL features. And it also demonstrates doing AST transformation with this plugin API.
So if you want to learn more about Weasel, we have a new website where you can find the user documentation as well as the specification for our extensions. And there you can also find the playground. On the playground, you can try your shaders and see how they translate to native WGSL without installing any of the linkers. We are also excited to say that Bevy has merged initial support for Weasel, and we are very excited about continuing this collaboration with them. And by the way, if you are working on a project in WGSL and you would be interested in trying Weasel, we would be happy to hear from you and get your feedback.
And shout out to Charlotte, who did this example in Bevy and Weasel. Here's a slide from a few months ago where we said we'd start out with the top community features and then prioritize what's most important to you and iterate from there. I'm happy to report that we've made pretty good progress. And now we need to know what you'd like us to prioritize for this year, for 2025. So thank you very much. Please give Weasel a try. Let us know what else you'd like to see, and help support the movement for common tooling and shared libraries for WebGPU. Thank you. Maybe I should give you the mic.
I'm probably loud enough.
I have a feeling those guys won't be able to hear you.
Yeah. Make it hard. Okay. At some point in the indeterminate future, there will be a version 2.0 of probably everything that WebGPU has to offer. And I was curious what strategy you have to support the Weasel things that you're making today. If the language, if like the core language of Weasel moves forward past it.
Yes. Well. Do one of you guys want to take it? I don't have a mic. You can't hear me. Huh? Oops. Yeah, we cut the talk down a little bit for time, but we have a plan to use edition tags so that published libraries in Weasel or Weasel will be tagged with a version number, and tools will support the old tags. So essentially the linkers will understand old Weasel and convert to current Weasel. Make sense?
Yeah, the Weasel have something like specialization constants in security, or if I have security with specialization constants, can I put those into Weasel?
I don't really know specialization. I don't know. Stefan and Matisse, do you know this one, or?
I can offer some
I
help.
didn't quite catch the question.
No, specialization constants in security.
Yeah, so specialization constants and security are equivalent to like the pipeline constant overrides
Ah, yes.
that we have in WebGPU.
Okay, then I have an answer.
Okay.
Yeah, so yes, so we have the ability to define constants, which we translate externally at runtime in host code in Rust or JavaScript, and those are injected into source code in Weasel as constants. So if you can express it as a const in Weasel, we can do that now. And if there's more things you want, then tell us and we'll add that. Sorry, I can't hear you.
Your roadmap slide mentioned polyfills.
Ah, yes, polyfills.
What are some examples of some polyfills that are on your roadmap, or things that are specifically not on the polyfill roadmap?
Yeah. So the things that I was thinking of when we wrote polyfills, one is something like this 4957, the binding structs that we showed that example of. So that would be an example where we could polyfill something that doesn't exist perhaps on all browsers or any browsers yet. Similarly, we could try doing something like many people have asked for swizzles, swizzle assignments. So we could try doing swizzle assignments in Weasel, and then people could use it right away, even before it's available in any browser, or maybe it's available in one but not the other browser so far.
Does that mean does that mean the polyfill the kind model autonomous GPU task launching where in the polyfill is like back to the CPU with the working
you can kind of model what would happen in the future with ways sort of kind of subgroups, on the variable ranges area and all that stuff. Like that means.
No.
Well, I mean, it would be nice.
Right. So, kind of our exercise is to see what, I think Ken was calling ergonomic features, right? We can do stuff, we do stuff outside of the browser core. We can make Weasel, help make Weasel more ergonomic and maybe, create features that can then be adopted into Weasel as ergonomic features. But we're a small part of the problem, right? The hardworking teams, who are actually working on the browser, they have to do, bind lists. They have to do the real enabling features. We can help do some of the, exciting sugar on top. Thank you all.